Hello, this is Varun, and in real numbers, next we are going to start with a theorem. And the theorem is, let p be a prime number, and if p divides a square, then p divides a also. We have to use result of this theorem many times in the questions. We are not going to do its result. I am just going to explain you what this theorem actually is. We know that 3 is a prime number. 3 is a prime number. Now, let us choose any perfect square which is divisible by 3. Let it be 36. 36 is divisible by 3. So we can say 3 divides 36, or we can even write 3 divides 6 square, because 36 can be written as 6 square as well. Also we know that 3 divides 6. So here we can conclude that if 3 divides 6 square, then 3 divides 6 as well. We can even verify this thing for some other set of numbers. Like we know that 5 is a prime number. And we know that 5 divides 100. We know that 100 is a perfect square, and we can write 100 as 10 square. So here we write 5 divides 10 square, and also we know that 5 divides 10. So here we can conclude that if 5 divides 10 square, then 5 divides 10 as well. So from these particular cases, we can generalize that if p is a prime number and if p divides a square, then p divides a also. Now we have to use this thing to solve various questions. So let us start with the questions now. Now in rational numbers, next we start with one more type of questions. We know that square root of 2 is irrational because its decimal expansion is non-terminating and non-recurring. That's why it is irrational. But there is one more way to show that root 2 is irrational. Today we will discuss that way. Well students, we will do this question by using contradiction method. In contradiction method, we suppose that the contradiction of statement is true. Now what is the contradiction of this statement? We have to prove that square root of 2 is irrational, and the contradiction is square root of 2 is rational. So in contradiction method, we will suppose that square root of 2 is rational, and then we prove that the things that we have supposed, they are wrong. And if the things that we have supposed, they are wrong, that means square root of 2 is not rational. Obviously then it will become irrational. So let us start now. Let us suppose that square root of 2 is rational. If it is rational, then we can write square root of 2 as p upon q, where p and q are co-prime integers and q is not equals to 0. If square root of 2 is rational, then it will satisfy all the conditions of rational number. This is what we have written as square root of 2 equals to p upon q. So by cross multiplication, we get square root of 2 into q equals to p. Now we will do squaring both sides. On squaring both sides, we get square root of 2 into q the whole square equals to p square. Now square root of 2 the square is 2 and q square is q square equals to p square will remain as it is. Let this be number 1. Here we have written p square as 2 into q square. It means p square is a multiple of 2, or we can say that 2 is a factor of p square. Or we can even write that 2 divides p square. If 2 divides p square, then we know that 2 divides p also. Now this result is from this theorem that we just have done, that if p is a prime number and if p divides a square, then p divides a as well. If p divides a square, then p divides a. So following this, if 2 divides p square, then 2 divides p also. That is, we have written. Now if 2 divides p, then we can write p as 2 into something, and let that be a. Let this be number 2. Well students, now we have found that the value of p is 2a. This value of p equals to 2a should be substituted in equation number 1. So we will write from equation 1 and 2 what we get. We get 2q square as it is, and I am going to replace this p by 2a. It will become 2a the whole square. So it will become 2q square equals to 2 square is 4, and a square will remain a square. In next step, when we shift this 2 to right side, we get q square equals to 4 upon 2 is 2a square. This is by cross multiplication. Again, we will follow the same steps that we did here. If q square is written as 2 into something, it means 2 divides q square. If 2 divides q square, this means 2 divides q also. Now we have proved that 2 divides p and 2 divides q. It means 2 divides both p and q. So we write as 2 divides both p and q. It means p and q are not co-prime, since 2 is their common factor. So from here we can conclude that p and q are not co-prime, because 2 divides both p and q means 2 is common factor of p as well as of q. But in the beginning of question, we suppose that p and q are co-prime. And here we have proved that p and q are not co-prime. It means we are contradicting ourselves. So here we will mention that this contradiction has arisen due to our incorrect assumption that root 2 is rational. Means our supposition, our assumption is wrong. So we concluded that root 2 is irrational. That's it. Thank you.